Greetings, ACT Specialist. Commander King here again, this time with one of the more challenging problems that you might face. And we'll take a look at why. So let's try to understand this problem first. So we have 49 grams of H2SO4, this thing right here. We're mixing it with 80 grams of NaOH, fair enough. And we want to know how much reactant will be left over after the reaction is complete. So if I'm understanding this correctly, I'm thinking, okay, one of my reactants, one of these two things, is going to be left over. In other words, I'm going to use up one of these, maybe the H2SO4, and if I use all that up, I'll still have some NaOH left over that's just going to sit around and do nothing. I don't know how much is left over. I don't know why. Maybe I could store it away for later or later use. Or I might just want to know for safety concerns. Okay, so fair enough. So it sounds to me I need to figure out which one runs out first, right? And if I want to figure out which one runs out first, I'll make you note that sounds like a basic limiting reagent type of problem to me. So maybe that's where I'll start. And then maybe once I can figure out which one runs out first, well, there's going to be some amount of the other one left over, and maybe I could work on that somehow. Okay, so, all right. Okay, so I'm going to treat this as a limiting reagent problem and then figure out how much is left over. So that's my plan. Will it work? Well, let's just run through it and see. Now looking at this equation, just to make sure it's balanced, we have 2 H's here, 3 H's, and only 2 H's here. So I know it's not balanced. The H's look a little bit tricky to balance. So why don't I start with the NA's? The NA, there are 2 NA's here, I only have 1 here, so that's an easy one to balance. 2 right there, and now let's look at my H's or my O's or whatever. I have 2 H's here, 2 more here, 4 H's. I only got 2 H's here, so let's try that. That gives me 4 H's on both sides. Check everything out. 1S, 1S here, 4 O's, 2 O's, 6 O's, and then there are also 6 O's here. So this looks balanced now. All right. So again, I'm trying to treat this as a limiting reagent reaction, so I'm going to figure out how many moles of, let's do H2O. I think Na2SO4 will be easier because it's a 1-to-1 ratio or 1-to-2. Well, it might be the same, right? Because there's a coefficient either way, and in one of them we're going to need to do a more difficult, quote-unquote, more difficult conversion. All right, so what do I have? I got 49 grams of H2SO4. I've got 80.0 grams of NaOH, and I'm trying to figure out how many moles of H2O they can produce so I could decide which one's going to limit their reaction. So I can't convert from grams to moles directly, or at least grams from H2SO4 to moles of H2O. I've got to get to moles first. I got to know how much of this stuff I have. So I'm going to start with just the H2SO4 and do these steps together. 2 conversions to get there. So it looks like I'm going from the grams of H2SO4 to the moles of H2SO4, and then finally to the moles of H2O. So it looks like a 3-step process here. I'm starting out with 49 grams of H2SO4. In order to convert to moles, from grams to moles, how do I do that? Grams to moles. Oh, right, the periodic table. I have the molar mass there, which tells me how many grams per mole. So let's take a look at that periodic table. I have H2SO4, if I recall correctly. So I've got 2 H's, 2 times 1.01, plus S, 32.07. Right here is S. Plus 4 of these O's, 4 times 15.99, or about 16.00. If I do that on the calculator, I should get 98.09 grams, and remember, the molar mass tells us how many grams are in 1 mole of that. Okay, so fair enough. Going back, I know I have 98.01 grams per 1 mole of H2SO4. When I convert, I'm trying to cancel out the grams. I'm trying to get to the moles of H2SO4. And I know, in 1 mole, there are 98.01 grams of H2SO4, and that gets me to moles. So that's my first conversion there. That got me to moles. If I want to calculate that there and stop there, I'll fill it in just to be consistent, but that gives me about 0.50 moles. So it would be this calculation. But I'm going to keep going because I don't want to stop just at moles here. I want to keep going to moles of H2O. And to go to moles of H2O, well, let's see, I'm at moles of H2SO4. I'm trying to get to the moles of H2O. Do I have a conversion? From mole to mole, I know I need a mole ratio, and not the periodic table, the chemical equation seems perfect for that, because I know for every one of these H2SO4 molecules I use, I can make 2 H2O. So for every one H2SO4, I'm making 2 H2O, and so the 2 goes in front of the H2O. And so I'm just taking that, multiplying by 2, and we can see, 0.50 times 2, that's about 1.0 moles. So what I just figured out is with 49 grams of H2SO4, I can make 1.0 moles of H2O. Not bad. All right, not bad. But let's see what this NaOH has got, because I don't know if there's more or less of it. So let's turn to NaOH here. Again, same type of conversion, right? Same type of conversion, but now just with different things. So I'm still going this time from grams to moles, but I have grams of NaOH this time to moles of NaOH. So that's different from the previous one. And this time I'm going from moles of NaOH to moles of H2O. Okay, again, 2 steps. Here's step 1. Here's step 2. Okay, I've got 80.0 grams of NaOH. Okay, times, well, let's see. I need to go from the grams of NaOH to the moles of NaOH. So I'm thinking, what conversion do I need from grams to moles? All right, the molar mass, because that has the grams and moles in it. All right, so we know we have NaOH. We've got 1 Na, 22.99 right here. We've got O, 16.00, and we've got 1H, about 1.01, and just adding that up, 24 plus 16 looks like about 40.00 grams per 1 mole. Wonderful. Oh, wrong problem. Let's go back to this problem. So I know I have 40.00 grams per mole. So in 1 mole, there are 40.00 grams. Oh, that looks convenient. That looks like it would be 2.0 moles. Oh, sorry, wrong box. Wrong box. I did not figure out the moles of H2O yet. I've only figured out the moles of NaOH. If I were to plug that in, I would write that in here. 2.0 moles of NaOH. But let's keep going, because I don't want the moles of NaOH. I want to take a second step and go to from in 1 mole of NaOH. Okay. Oh, sorry. Now I'm going from moles of NaOH to moles of H2O. So actually, in 2 moles of NaOH, there are 2 moles of H2O. In other words, they're 1 to 1, so I'm fine with putting 1 to 1 if you did that quick calculation. But 2 over 2 is 1, so I know I'm still making 2.0 moles of H2O. Okay, now I've got to think which one is limiting, right? Well, with this H2SO4, these 49 grams, I can make 1.0 moles. With these 80 grams of NaOH, I can make 2.0 moles. But that's nice, I can make 2.01 moles, but my H2SO4 is going to run out, and I can end up only making 1.0 moles of H2SO4. Okay. All right, so what have I figured out? Let's conclude here. I figured out that my H2SO4 is limiting, and my H2SO4, it can produce 1.0 moles of H2O. On the other hand, my NaOH is capable of producing 2.0 moles of H2O. Okay? So, in other words, the NaOH can produce double the H2SO4, right? And in fact, the NaOH can still produce another 1.0 moles of H2O, right? Because it could produce 2.0, but it only produced 1.0 because of the H2SO4. So really what I want to do is with this 1.0 H2O that it's still capable of producing, I'm going to convert that from moles of H2O back to moles of NaOH and back to grams of NaOH. Okay, and that'll tell me how much of this grams of NaOH is left over. On the chart here, here's another way to think about it. It's like, okay, so if I'm making 2.0 moles, NaOH could make 2.0 moles, but I only made 1.0 moles. So I still have 1.0 moles of H2O possible to be produced, and I'm going to convert backwards. I'm going to convert back here and back here to see how many grams are left over. And so if I do that, I know in 1 mole of H2O, there are 18.02 grams of H2O. That's from the periodic table. And then, oh, I'm sorry. I don't want to go to grams of H2O, right? That's not the direction I want to go. That's if I wanted to go up. But remember, I'm going from moles of H2O to moles of NaOH. So in moles of H2O and 1 mole of H2O, well, let's see. Well, actually, it's in 2 moles of H2O, I can make 2 moles of NaOH. Yep, in 2 moles of H2O, I can make 2 moles of NaOH. And now I can use my conversion. In 1 mole of NaOH, I can make 40.00 grams of NaOH. And so 2 over 2 cancels out, that's just 1. So actually, you'll have 40.00 grams of NaOH left over. And if we think about it, so the NaOH could produce double the H2O, so only half of it was used up, and we still have half of it left over. All right, so that's one way to do it. I'm going to leave it there, and then I'm going to show you another way to do it in the next video. All right, King out.